So this presentation actually includes two presentations about two Italian manufacturers of slide rule, Marcantoni and Filotecnica Salmoiraghi. And there is a plurality also in the fact that it's the fruit of the efforts of three people. I'm only one of them. The other two are G.Breda and A.Celli. Andrea has joined previously some IEMs, so maybe you remember him. Giovanni, I think, has never been to an IEM, but he has a nice website. So maybe you came across his website and you have seen what he's been able to do. Or maybe I should switch it on, I don't know.
Let me see. Those are the very small ones. You need glasses for that.
Ah, there you are. Okay, thank you. Okay. So this is what I already said. The proceedings contain two separate articles, one for each of those manufacturers, but the presentation will cover them both. Let's start to give an introduction about the slide rules in Italy. Slide rules in Italy started to be relatively well known after the publication of this book, Teoria e pratica del regolo calcolatore, Theory and Practice of the Slide Rule, by Quintino Sella. Quintino Sella has been really a polyhedric character. He was a scientist, an alpinist, and also politician. He studied in Paris, and this is where probably he learned about the use of the slide rule. In Italy, the slide rules were built probably after this book, and in the last century they had to contend with especially German companies like Nestle, who were already invading the market. Some of the places where we know there were Italian manufacturers of slide rules, they were close to the centers of industry, so mostly in the north, or almost exclusively in the north. So Neot was near Bergamo, Marcantoni, Salmoiraghi, and Technologic were in Milan. Vittorio Martini was and still is in Bologna, and there is this little known company, Ochip, in Florence, and I know that Andrea is particularly careful and is about this, particularly interested in it, and maybe there will be a follow-up to these articles with something really new. These companies that we are talking about, that we have just mentioned, have had different evolutions. So Salmoiraghi, that has been a very important manufacturer of precision instruments, more than slide rules per se, is now just a brand. It's an eyewear brand. Neot and Technosteel still exist, and they are producing drawing equipment. I don't think, unfortunately, they will last for much, because nowadays, whoever has to do a drawing will use a computer and printers. Vittorio Martini instead is producing luxury pens and pencils, and Marcantoni and Ochip completely disappear. So,
you stay here, and then it's easy to people
okay.
have it over there. And you have the pointer, so with the pointer you can indicate. So stay over here.
There.
Halfway the room, it's easy
Well,
for people to do it.
And if you speak more that direction.
Okay. So let's start speaking of Marcantoni. It's a small company, we'll see. Marcantoni is a name of someone, so a certain Mr. Marcantoni must have existed. And we managed to find something about it. The interest on Marcantoni started probably after an article by John Sinclair on the Slide Rule Gazette in 2003, where he describes how he came across the slide rules, first in Florence, and then when he had to go to Milan, he heard about the last known location of the company, and he managed to find a place in Bresso, which is immediately north of Milan, and he has basically taken all the slides he could, and he has written an article on it. However, to have a better knowledge, we had the idea of asking the Chamber of Commerce of the city of Milan, and we have been able to receive a thick dossier with all the information that could be possibly useful. So we have been able to reconstruct the history of the company at least until the 1960s. The company started in 1937 with the name Fabbrica Italiana Regoli Calcolatori, and it was a partnership of two people. One was Giovanni Marcantoni, the namesake of the company, and a certain Edoardo Savani, of which we don't know much. Probably Mr. Savani was someone who was able to finance the project. Mr. Marcantoni is named in the documents as a cabinet maker. The company then changed its name after just a month and becomes Fabbrica Italiana Regoli Calcolatori G. Marcantoni E.C. So the name Marcantoni starts to appear. And then in 1937, in April, they deposited this logo. You can see that it is a sort of stylized slide rule. It's a very simple one. The company continues to move around, and eventually in 1941, the company was moved to the actual residence of Mr. Marcantoni in Via Bramante in Milan. Then in 1943, so when the Second World War has already well started, unfortunately, and Italy was really in bad shape, because in 1943, basically in September, Italy concluded an armistice with the Allied powers, and of course the Germans were not very happy about that. So Italy was basically split in two, the northern part being ruled by Mussolini and the Nazis, and the southern part, at least nominally, with the king. So in 1943, Mrs. Marcantoni became a minority shareholder. The name changed again to Prima Fabbrica Italiana Regoli Calcolatori, so the first Italian manufacturer of slide rules. In 1943, in the same year, in 1943, the capital is lost. So we can imagine that this was due to the war. And the company restarts with Mr. and Mrs. Marcantoni as only shareholders, with a capital of 50,000 lira. That was not much by the time. But they deposit a new logo that you can see that there, and it's probably the one that everyone who knows Marcantoni slide rules has seen. After the war, in 1958, Mrs. Marcantoni quits the company, and a new partner is found, a certain Mr. Carlo Beretta, and the capital is divided equally between the two partners. In 1962, the company moves again and settles in what probably was its last location in Bresso. And after this date, we have no more information. The Chamber of Commerce has purged Marcantoni from his records by default because they didn't have any information, and this happened in 2010. Some of the achievements of this company. In 1939, Marcantoni was awarded a gold medal by a local foundation, Istituto Lombardo di Arti e Lettere, and the the mention says that the Commission is pleased to recognize the full implementation of the National Plan of Self-Sufficiency. This means that Mr. Marcantoni and his collaborators were trying to use as much as possible Italian materials, and they wanted that Italy became self-sufficient also in slide rules or calculating equipment. In those years, in the late 30s, Italy was under the so-called, there was a sort of boycott that had been decided by the Société des Nations, which was one of the precursors of the United Nations, because Italy had invaded Ethiopia in 1936 and 37, and so Italy was punished, and the effects of this boycott was that many raw materials were not coming to Italy anymore, or at least in theory. So the idea that someone was doing slide rules when other countries would refuse to supply them to Italy was considered a good thing, and Mr. Marcantoni and his company were prized for that. The mention also says that the company at that time employed only 20 workers. But Marcantoni planned to supply the entire country with his slide rules. I think it was a bit of a pipe dream. Also considering the fierce competition by the Nestlers and Faber-Castells of the time, and Alstom. Another interesting point is that this mention says that Mr. Marcantoni has invented himself a dividing engine, and now is building another one. So this tells us something. This Mr. Marcantoni was not just a generic cabinet maker, but probably had something in his brain. Another achievement was this patent, a patent that has been submitted in 1942 for a slide rule that would determine the weight of a bar or any material, metal, having a constant cross-section with only one operation given its length and a shape parameter. So the idea is based on this formula. If you replace K, which is these shape parameters, with pi divided 4, and consider that the cross-section would be a circle, you immediately recognize this is a well-known formula for calculating an area. So the advantage would be to avoid successive multiplications and also having to square numbers. And the trick that Mr. Marcantoni thought of was to introduce another parameter called the K apex, which is actually 1 divided pk that we have seen before. So this K apex only depends on the geometry and the specific weight of the material, and the formula becomes this one. The values of K apex for the most usual materials are to be placed on a logarithmic scale on the slide rule. So this is what happens. So to calculate the weight of the bar, you have to take the K apex value for the chosen material over the diameter value. The end of the slide would then point here, where you have D divided K apex, and then taking the square of this, you would get the number you wanted. Okay. This with a very simple movement, but there is a but, and in fact that's the reason why this section has been titled a questionable patent. If you think of it, the procedure is flawed because with that definition of K apex that has been given, what you get is not PKD squared, but P squared, K squared, D squared. Okay. The procedure would be correct if K apex were defined as the square root, 1 divided the square root of P and K. And it seems frankly strange that this mistake could have slipped through and the patent could be granted. However, the patent has been given, and among other things, the patent includes also a variant of this procedure where instead of using a separate scale, there is a special cursor with different lines that gives the same result. Probably also this one would be flawed. But we have not been able to find a slide rule in the range of Marcantoni slide rules we know of that uses this patent. There's been another patent, not so clear, that is shown in the catalog of 1951. This patent number is this one, 5145/44, which makes us think this has been granted in 1944, when, as I said before, Italy was split in two. And this could be the reason why it has not been found. It's only mentioned here in this image of the catalog. Okay. So maybe the patent granted in that period of 1943 to 1945 went lost because of the war. So we have not been able to find these things. By the way, this is a slide rule for the textile industry. The cursor has many different lines, and with that one could make a number of calculations for the textile industry, like the yarns and all these things that I'm not very knowledgeable about. Let's see other slide rule models. These are also not so usual. The first one is a calibro regolo. So it's a caliper and slide rule at the same time. As you see, there are two logarithmic scales on what we could call the stock, and the movable part has one logarithmic scale. And there is another nonius, is that the right term in English? Yeah. For that is that normally appears in any caliper. The second one is really something curious. It's not really a slide rule. It doesn't do any calculation, but it gives us the size of buttons, like the buttons for your shirts, in different units of measurement, including one which is called Punt de Paris, that we have not been able to find anywhere. So we don't know exactly what it was. If you know something, let me know, please. So these images are taken from the catalog of 1951. Another interesting model is the picture is taken from the collection of Giovanni, but it is also in the catalog of 1951. This is a chemical slide rule. You can see, maybe it's not very clear, sorry, but there are here the atomic weights of several chemical species, and then there are normal scales that you would expect to find in a slide rule. On the back, there are constants and data. These are instead slide rules for reinforced concrete. This image is taken from the catalog, and this one is taken from G.Breda's collection. So these slide rules have different scale arrangements, are made of different materials, but curiously they share the same model name, 25CA. CA like cemento armato, reinforced concrete. And this is another example of an unusual slide rule. This is a workshop Technologic slide rule. And this is based on the work of one unknown, Mr. Dondi, an engineer, who had elaborated about the most efficient utilization of workshop machines. So he had found that once you know the cutting speed of a machine and the duration of the cutting edge, then you can calculate all the other important quantities that determine the efficiency of the machine. Examples of something like this are also known for other manufacturers. For instance, I think there was an Aristo slide rule that did something like this. But the particularity is that it seemingly has been based on the work of this gentleman that we don't know about. It's also possible that this Mr. Dondi has really contributed to this thing, but as John St. Clair already noticed in 2003, there is a possibility that Marcantoni review. Filotecnica has been one of the most distinguished Italian companies producing precision equipment. We will see what was the history of some of these slide rules and calculating machines. And this is a more ancient company than Marcantoni, because the origins go back to the 1800s. And the story of the company ends in 1969, when the company was sold, I think, to Alitalia. They were active at the time in avionics, and so that was the end of Salmoiraghi, except in the name that still remains as the name of a chain of retailers of eyewear, Salmoiraghi Vigano. And if you happen to be in one of the big cities of Italy, probably you have come across one of these shops. I know about the name Salmoiraghi, Filotecnica, and Filotecnica Salmoiraghi will be used interchangeably, and we will see why. So let's start with the company history. In 1964, this gentleman, Paolo Ignazio Porro, founds the Officina Scuola Filotecnica. I think the name of Porro could be known because Porro is the inventor of the famous Porro prism that is used in binoculars, for instance. He wanted to train a group of young people, young men at the time, and that's why he started this Officina Scuola. So it was a workshop and a school at the same time. So young people will learn a trade, and at the end they will be refined back to 1884. I have to say that this study has been possible thanks to the massive collection of documents that Andrea A.Celli has got. Thanks also to the fact that he has been working now, I think he's semi-retired. He has been working in an institute of the Italian research institutes called the Istituto Applicazione del Calcolo, so Institute for the Applications of Computation. So back in 1984, we are with the first catalog we have been able to find, and the list of calculating tools only takes half a page. It's a tiny part. This is a reprint of this thing. You see with the prices.
a catalog number. I would like to point out that this number 198, circolo logaritmico, logarithmic circle, and then the number 200, a logarithmic slide rule for tachyometria, which means the fast method to do surveying. This is the logarithmic circle, and this is the topographic rule, and the topographic rule was called Regolo Tachiometrico Soldati, after a certain Mr. Soldati who had designed it. The following catalog at the beginning of the 1900s show a so-called begin slide rule. These were also produced by Gravé. And it is not clear if Filotecnica was actually producing them or reselling them with its brand, but we don't have a picture. There were two models of reeds, slide rules, 25 and 13 centimeters in mahogany, and the smaller model and also a magnifying cursor. And also for this, unfortunately, there is no picture. Then there is a third one, which is called the definitio rule. So we don't know exactly what it was, and we don't even have an image. The catalog describes it as made of mahogany with celluloid scales, that is 5 centimeters. With this slide rule, it is possible to calculate the product of 3 factors of the division of a number by the product of other two with a unique movement of the slide. And I think this is the main advantage of the begin rule. So it is not clear how these begin rules managed to enter in the range of products by Salmoiraghi, excepting that this one is probably original because it's been designed by Mr. Definitio. In the 1930s, we noticed a so-called precision slide rules with a length of 25 centimeters. On the back, there is a scale for squares and cubes and so on. And they claim the precision of this, in spite of being only 10 inches long, was the same as a 50 centimeter or 20 inches slide rule. And there was also a slide rule for electricians that does the things that we know an electric slide rule does, with dog-log scales, yields of motor and dynamos, voltage drops, you name it. Okay. Unfortunately, there are no pictures about them, and we don't know much about them. In this period, the logo changed to this one, and this is the logo that is shown in that catalog. And we start seeing now proper slide rules in the 40s and 50s. So these are pretty ordinary slide rules with this one I had both a 5-inch and 10-inch versions. This one is a 4-inch version. This is a slide rule of a bigger size. Actually, it's available in 3 lengths, 50 centimeters, 25 and 15. Note that it's funny to me, but note that the catalog number is as numbers that are the reverse of the length. So 50 becomes 0.5, 25 becomes 52, and the 15 centimeter becomes 5.1. God knows why. This is a specialized slide rule for reinforced concrete. So 25 centimeters, no trigonometric scales, and there is a leather case. This is an electrotechnical slide rules. So this is something we already described. Okay. And there is another one that instead of being 25 centimeters is just 15 centimeters long. And then we come to the jewel of the crown, I would say. In the 1950s, end of 1950s, as we have been able to reconstruct, considering the percentage of sale taxes. So we know that in those years the sale taxes were those announced in the catalog. We find this logarithmic calculator. It's not as properly as slide rules. It's a machine. It's something that is this long, this wide, and this tall. And the claim that made it special was that it was supposed to have the same accuracy of a linear slide rules of 2.5 meters. I don't know if the claim was justified based on something we will see, but anyway, it was a good selling point. And they needed the selling points because the price was very high, 90,000 lira. The customer could also pay in installments, but nevertheless, it was quite some money. I remember my father was working as doctor in prisons. I think he started in 1953, and his wages were 30,000 lira a month. So probably 90,000 lira was at least a couple of months of salary of a professional. This machine was designed to be used with the left hand, leaving the right hand free for taking notes or writing numbers. It has 9 scales, the scales that you would expect in any slide rules: sine, tangent, the one-to-one numbers, square, cubes, logarithms, and small arcs. We know the patent coming from 1951, and the inventors mentioned are Vincenzo Quilecchia and Mario A.Celli. They were both military, and maybe the name of A.Celli reminds something, because in 2016 Andrea A.Celli presented in Trento a very small calculator that had the size and the shape of a cigarette lighter, and that was also another brainchild of Mr. A.Celli. The scales were printed on microfilm. As I said, the price was almost unaffordable, and we know of the existence of only 5 of these calculators, which is in agreement, I would say, with the fact that the price was so high. So commercially it was surely not a success. I hope you can see this because it's a bit weak. This is the cross-section, but I think it's in a better shape in the proceedings. This is the cross-section of the machine. So there are these 2 control knobs that could rotate independently of each other. They control the rotation of 2 discs here. The 2 discs bear the graduations. There is a vernier that allows a micrometric displacement of the scales. There is a low voltage lamp that is fed via a transformer from the AC mains. There is a condenser and a lens, and the image is then by a mirror projected onto the screen that is visible from outside. And of course there is an on-off switch. I think that the most difficult thing was to have the discs that were exactly concentrical and real circles, a minimum of ovalization, let's say, deformation, making them ellipses rather than circles, could destroy the functionality of the equipment. These are two actual pictures taken from the machine that Andrea owns. You can see here the two knobs and the two discs here, the mirror, the vernier. It has to be noted that also the knobs have a gross graduation, a logarithmic graduation, that could help the operator to find the number they wanted to operate on, or the numbers they wanted to operate on, without having to continuously look at the screen, because of course they had to rotate quite some time in order to get to the right number. This is a detail of the two discs. And this is a comparison of the results obtained by that calculator with the exact result and the percentage error. This has been published on a trade magazine by Mr. Bruscaglioni. We don't know if we have been somehow paid by Salmoiraghi, but surely Salmoiraghi, given the high price, could not let any opportunity to have publicity slip. So we see that the error is low, but it is not that low. Okay. Here you see sums and subtractions. I think they were performed using the notorious formula A plus B equals A multiplying 1 plus B on A. And also for the multiplication, the things were going a bit better, but not so much. Okay. So this is the end of the presentation. Thank you for your attention, and I hope that in the future we will be able, the three of us, Angelo, Giovanni and myself, will be able to find something more to say about Italian slide rules. Italy is not well known as a country of precision engineering, and I think this is maybe a misconception. So I hope that with our work we are placing Italy on the map for this kind of equipment. And that's it. Thank you.